Morning, Matteo, and thank you for agreeing to this interview. We met at the Al Gore event in Rome a year or so ago, and I was very interested in your groundbreaking first underwater cultivation system, and I'd like to be able to address some of the ways it can meet pressing global challenges in terms of how to meet food security, climate adaptation, biodiversity, and how this project is maybe relevant to coastal communities. So with that, can you start with the origin story, what inspired this underwater farming approach?
Okay, so this underwater farming approach stemmed by a very long experienced company that dealt with producing scuba diving gear, for which Genova is one of the birthplaces in the world. All the main let's say, brands that you would know, Ocean Reef, of course, but also Cressi, Mares, Scuba Pro, they were all born here. So like sometimes happens, a very hot spot came out. With that, a lot of experience on managing underwater and pressure. So that is something that it's not easy doing what we do, and it's one of the critical know-hows that make our technology unique and interesting. To give you an example, Ocean Reef still produces, of course, a lot of forward equipment for scuba diving, like the full masks, and it is a NASA supplier, because the NASA project for going back to the moon, some of the equipment is produced by Nemo's Garden. So to give you an idea of how technology is relevant and how Ocean Reef Group, from which Nemo's Garden is stemming, it's a key player in this technology.
Wonderful. Now, the technology that has evolved from Nemo's Garden is essentially biospheres, which are inserted in a marine environment and use solar energy, seawater-based humidity, and essentially use the natural environment for carbon capture in these biospheres. Can you explain how these underwater spheres can produce agriculture and herbal products?
So in a nutshell, and if I can share some video, I'm gonna show you what we're talking about. So this is a biosphere from top, and from where you can see a lot of condensed water, and I'll get back on that later on. And this is a vision of the biosphere. So to give you a very clear vision, it's open on the floor. So there is an open surface, exchange surface with the sea. There is a bubble of air inside, and we basically work using hydroponic technologies, which are very common now in the vertical farming and very, very good in managing resources, some of the resources, as an example, water. And basically we can use the biosphere to grow. We already tested more than 150 different crops. So of course there must be some preference for an environment that is very humid. There's a lot of humidity, but we have extremely interesting results also because we have a pressure inside of the biospheres. So basically there is air inside. The sea acts as a thermal regulator, so we do not need what is needed in the traditional vertical farming to maintain the temperature of the growing site, cold or warm, depending on what's the temperature outside. The sea, it's very soft in the thermical movements, so it have fluctuations of 2 degrees, 1 degrees, night, day. Seasonally speaking, it's very again soft. So we can guarantee the perfect temperature inside, provided by the sea with no cost, which is not an irrelevant observation, because one of the main costs of the vertical farming is energy to maintain temperature and to provide light to the crops. Concerning the lights, we do not need lights because the sea provides the sunlight is sufficient to reach the biosphere. Of course, we have some frequencies that are cut, so we do not have red frequencies. Usually, the biospheres are between 4 to 10 meters of depth. And so we have some green and a lot of blue frequencies, of course. So let me go on with the presentation. So this is a typical farm. Is a pilot site in Noli. Every of these biospheres can produce about 100 crops, plants, plus it has a lot of real estate for microgreens. Microgreens are becoming very interesting, especially for nouvelle cuisine. And I'm going to get back on that. It's very important because each of these biosphere can produce, let's say, 8 to 9 trays of microgreens, which have a very interesting cost per hectogram. So they become one of the possible business applications of the farms. Getting back to the technology. So why we did this? We did this because we know that the land and traditional agriculture, like we know it, it's very impactful in terms of CO2 emission and land impoverishment. It's very impactful again. So we think that providing a solution that can basically do not use land, it can become a very important replenishment area because of the FAD effect that it provides in the areas where we install them, meaning that we have much more fish population and much more fish species in the areas where we have the farms. And if you combine this with the fact that in the areas where we have the farms, you cannot go with boats or fish, this can become, for bigger farm, we did a study, it could become a relevant replenishment area where that could benefit all the areas around for the coastal fishermen communities. So we have a very interesting circular approach and vision, and with a lot of side effects, we call them, that are very good for the full community. So yeah, it's an alternative farming system where it can be used. Of course, it has to have certain characteristics, the regional characteristics, but it can be used in every coastal region. So where there is the necessary depth, the necessary protected waters, we do not need specifically protected closed waters, because our pilot site in Noli have withstanded very relevant storms. So we can also be out there in the open, but of course we are targeting areas where the situation can be the perfect situation. That is possibly in islands, in all the coastal regions within the tropics. So the Middle East, the Arabic Peninsula, all the possible islands that do not have a lot of water, fresh water, and a lot of arable land. Why? Because we do not need arable land, as I said. Hydroponics is applied, and we can grow several different crops. There's no need for pesticide and chemical treatments because the biospheres are completely isolated, and of course, it's a possibility that we don't even want to fathom. But in case of a nuclear fallout, the water would protect the plants. Salted water is one of the best filters to nuclear emissions. And then what I was saying before about pressure and specific conditions. What this means, we have an accelerated growth, meaning that plants have a quicker response, especially in the germination phases at the beginning. And we have organoleptic properties that are different, are enhanced. So, for example, in the basil, which is our, let's say, control plant, we do a lot of studies with universities and center. We know that we have more essential oils, more antioxidants. So the plants have a very relevant difference, which you can appreciate with the taste. But not only, it's also appreciated by, for example, perfumery specialists. We've been working with a main global player into perfumery and essences, and they have appreciated the special qualities. So that is another possible and interesting exploitable business possibility for a larger deployment. Of course, quantity is an issue, not so much in the sense of production, because it's not thousands of tons that they need. They need hundreds of kilos, which is absolutely doable. And it's a very interesting possibility. Then side gains, what I was saying before, biospheres act as reefs. So we have a lot of fish population gathering around them. And this is very interesting for the locations where we deploy the farms. And then the water, how we do produce fresh water. Basically, the biosphere, we call them biospheres for this reason, have a natural effect, which is the temperatures inside in the air has a differential with the temperature of the sea, because when the sun is heating down, there is a raise in the temperature. So we have the phenomena of evaporation, very easy, very simple, and the water condenses. At that point, is distilled water condenses in the internal surface of the biospheres. We collect that water and we pump it in the hydroponic system. So for areas where there's no fresh water in abundance, or let's say the Arabic Peninsula where fresh water is an issue, we have a very interesting solution, because we can be self-sustainable in terms of water supply, which can be a key driver. The temperature, as I said before, naturally stabilized by the surrounding body of water. So depending on the latitude where we go installing, it can be pretty controlled, because if here in the Mediterranean, the North Mediterranean, the seasonality it's stronger. We have more than 10 degrees of excursion. In places like the Red Sea or at lower latitudes, it can be very controlled. So we can guarantee very interesting production for the full year, let's say. We don't have seasonality like we have here in a pilot site. Again, natural light protection, what I was saying before, the harsh spectrum, which is the red, it's cut. The depth diffuse the light and produces these effects that together with the pressure can be appreciated in the quality of the plants. The pressure meaning, depending on the temperature, on the depth, of course, you can have, if you are at 5 meters, you have half an atmosphere of pressure. If you are at 10 meters, you have one atmosphere. And this stresses the plant in a way that results in improved organoleptic qualities. Technology, of course, we are part of technology because one of the most important things is to minimize the intervention of a human operator, because that in this scenario it's a cost higher than somebody that's going to check the greenhouses in a vertical farming. Of course, in many areas in the world, it's not such a differential cost, but it is. So what we have underwater communication systems. So we are connected. We have the possibility to gain all the information and relay the information to the land, to the control room, or to the phone of the plant manager, let's say. We have cameras. We're studying with these cameras several algorithms that can allow us to read somehow the maturity of the plants, when we have to crop, when we have to harvest, what has to be done. A lot of information we are getting from cameras again, and we have cameras constantly. So if there's any problem, if there's something going not the right way, we know where and when to send eventually the operator. We have Wi-Fi inside the biospheres, so this comes very handy with the experiential side of the biospheres. One of the business models would like to bundle the actual production with experiential visits from scuba diving or snorkelers. For the scuba divers that can go inside, we can allow, and we did this, and it's really exciting for the guests, have a call, let's say with Skype, no longer, but with Zoom at home or with WhatsApp. From the biosphere. So it's very interesting. It's very advanced. So thanks to the Wi-Fi, we have a lot of sensors and IoT and demand response applications. So we have, of course, I think I have them here. Yes, I'm going to give them now. Sensors, I'm going to get with the next slide. And then water production. So we basically have a Peltier cell that allow us to maximize the water production and collect it and pump it in the system with a little pump. And then there is a vent, which is a very basic vent that allow us to move the air so that the humidity does not stick too much on the crops, and the growth is okay. And so it's very important. So I was saying sensors, we have internal temperature, water temperature, internal humidity, internal illumination, lumen, we have all that type of information, oxygen and CO2. Because, of course, we need to know what's going on inside. We need to know what's going on inside when the operators are inside or the guests are inside. Because when you go in one of these biospheres, you can stay, let's say, 3-4 hours with no problem breathing. And then after a while, the CO2, the oxygen is finished because you've been. So you need to put your mask back. The interesting thing is that giving the water exchange in 24 hours, the oxygen is back at the right equilibrium with how it would be here in this room in this moment. So in 24 hours, it's perfectly replenish the balance between oxygen, CO2, and argon, whatever all the gases involved in breathable air. Again, this is a control room. Every farm can have this on the land, of course. It's a way to control many things. You can also pump air inside or switch on lights if you want to see, move the cameras, basically doing all the things that could be needed to manage remotely the biospheres. And then, yeah, this is our Italian pilot. The Italian pilot is in Noli, which is an hour west of Genova. We have, this is an older photo, we have 9 biospheres deployed now, and we tested some very interesting new shapes and designs that I'm going to show you in a couple of slides. The important thing here is that there's a lot of hype around an underwater farm. So we do not, we wanted to open the experience to everybody. So we do not charge for visits. Of course, nobody can go inside if not with us, but you can snorkel and go around. But this in certain location in the world could become a very interesting revenue point for an investor, because it could become an integration of the package, and this is a very relevant thing. We have a lot of feedbacks on this. Products. This is our Biosphere 1.1. It's a 2,000 liters volume inside, and it's very well tested. We deployed these in 4 different areas in the world. And again, the main driver for now is experiential, but we're starting to work with Michelin-starred restaurants. So also here in Italy, we are starting a collaboration for this summer with a couple of Michelin-starred restaurants. So that is another very interesting possible deployment. I mean, a very interesting business opportunity, depending on where is installed, of course. But in front of a major city, let's say Dubai, let's say Jeddah, wherever it is possible to find fine dining restaurants. The microgreens are very appreciated, again, because the pressure and the special conditions give the microgreens a very deep, interesting taste. So yeah, this is the 1.6 square meters of microgreens and 100 plants for each biosphere. 100 plants meaning basil, aromatic plants, but also tobacco. We've been testing several things, different things. Tobacco, we're using it for the production of gin, which is very interesting. So also the marketing factor can be an important angle to use for when evaluating this type of investment. We have a lot of media coverage. We have every main outlet covering us every once a while, from BBC to CNN, from the Washington Post to the National Geographic. It's very interesting. This is another solution we deployed last summer. It's very big. It doesn't look like from this picture, but it is more than 6,000 liters of air. And inside we can fit more than 400 plants in an environment that is much more similar to land greenhouses, so where we can get more off-the-shelf technology for hydroponics, which is a very good approach, we think. And again, the real estate for the cultivation of microgreens is very important. This is very tall, it's very big, it's really amazing, and it's less sexy design, but very functional, very concrete. This is the third that we tested last year. Is a geosphere. If you know what a geosphere is, we could even design it bigger. We did this design first of all because we think it's very interesting, has an experiential spot, but it's also very big. Inside, this is a 3 meters diameter, and inside there's more air volume than the tunnel that we saw before, than this one. And the interesting point is the logistics. We can build this underwater. So we can transport this and build it underwater without having to use a barge or anything too big that would require this deployment. Of course, if we are doing a big deployment, we need a barge, but this is very interesting. And inside is very big, so you can stand up and basically you have the water at your knees, slightly on top of your knees, which provides a very interesting feeling and experience for the user, for the visitor. So it's very interesting. And yeah, so to wrap up, we have 3 designs. One very well tested. The other ones that we deployed last year. We would be ready to do bigger deployments of biospheres. For now, our bigger deployments is 10 biospheres. Our bigger farm. I want to be extremely frank. No reason to not be that. We have made studies and calculation to do bigger deployments that could reach a cost per kilo that could be competitive with high-end supermarket. I mean, high-end production and sell in certain markets. Of course, these are calculation, our tests, but we are ready to discuss them. And again, there is all the ancillary sides effects, meaning the experiential, the tours, the possibility to grow a selection of plants for essence production, which can make an investment in this in our biospheres. Also very interesting from a financial standpoint, from an investment standpoint. This is a small production that we do for a Christmas gift, which is made by a maître chocolatier that has been studied with a 3-star chef, and these are really extremely delicious. We gather the plants, melissa, thyme, basil, and then we do this cream that we put in this very fine chocolate. And this has been a huge success. It's a very small production, but I just wanted to put it here to show the possibilities that come out from this type of production. And yeah, this is what I was saying before about the knowledge, where it stems for. Genova has been one of the hotspots of scuba diving, and Ocean Reef has been doing it very well. So well that for the Artemis project of NASA, they're using Ocean Reef masks for the testings. So this is also this is made by Ocean Reef, which is the mother company. Nemo's Garden is a spin-off. It's a completely isolated company, I mean it is, but it's a spin-off of Ocean Reef that has this very deep knowledge that is provided to the company. For example, here you see these masks. You probably see them in Decathlon. They have been developed by Ocean Reef. Yeah, Neom, the Hasemit Coat, DSM Firmenich, Siemens, Volvo, Edison. They're all clients and people that has been happy to work with us, and we're going to be happy to work with anybody that see and share our same vision and mission, because we believe that with a going to be 9 billion world, and we need to really invent something new. We did it. We need to deploy it, and I think I truly think that in certain locations in the world, this is going to be in the next 10 years, 20 years, but starting in the next 10, a real production hub for food. From here to the next 10 years, when it's going to become to do also salads, it's going to be a very interesting way to involve clients, snorkelers, scuba divers, and do niche production like essences, phytopharmaceutical applications, phytocosmetic applications, and so on and so forth, microgreens for fine dining, and so on and so forth. So
Wonderful. Wonderful, wonderful. I think this is a very good overview, and I just wanted to ask you a couple of things before we just wrap up. So you discussed the B2B partnerships you have with Edison, Siemens, the Hashement Court, Neom. What ways, or Volvo is, and what ways do you see the corporate business relationship evolving in terms of potential for ownership, joint ventures, or just what sort of or development of certain local areas? How would you look at opportunities in those areas?
Again, so so what how do we see potential corporate engagements with other clients, with other partners, or
Correct.
okay. Yes, of course. So no, we are looking for we are looking to open our cap table in the next year. If we find an industrial partner that can bring to the table several things on top of the money, of course, because we feel that we are at a point where we can be growing very scale very significantly, because we have been providing proof of concepts for several things, the microgreens and the plants, which are very much appreciated by top-notch chefs. And it's not only because it's cool to have the stuff growing underwater. They appreciate it because they're really, really interesting products. We have the possibilities that we're testing, be it the chocolate, be it the gin, be it anything that can be produced with the special plants and marketed with this amazing context that we provide. It's also tested. We just need to find the right people that say, okay, I believe in this. I have this type of contacts, business, whatever. So we're looking for that. We're looking for the possibility to discuss deployments. For example, we could decide to find the right location and make a deployment to produce essences. Only that. That could be a standalone business where we could add, of course, the experiential with possible tours and stuff, but that could be another option. So what we're looking for is a partner that see what we are seeing. In the future, this is not a cool thing. This is going to be needed because we need to grow in a more sustainable way. We do not use energy for the energy is provided by the sea, basically. We do not need LED lights. These are just decorations because for the experiential, they can ask us to switch on. But we have a very efficient circular way to grow stuff, crops, and this is going to be an asset. This is going to be necessary in the future. There's no doubts. and we
Yeah.
know how to do it.
Great. And one thing which I think we sort of skirted around was the actual, you're using nature to recover CO2 in the plant growing. So there is no carbon capture here other than what nature does.
Yeah, basically, we have the plants growing inside, so they do what they have to do. If there is when we go there is the sea that does what it's doing in the world every day. So it's
Absolutely.
managing 50+% of the CO2. But this is, I mean, in our we have also a further vision that we're looking for fundings from the European Union to do this. We could, if associated, let's say you have a beer factory close by, we could use the CO2 that is an excess product from the beer production and pump it into the biospheres to accelerate growth of the plants. So the idea is that, of course, that would have to be controlled to understand that we're not acidification of the sea because we are pumping a lot of it, but we're just pumping the right amount to improve and increase growth. So that could be another evolution to couple this with CO2 emitters. And another things that we would like to do, we're going to test this this summer, is to use discharge of sea farming, so algae or let's say shrimps, to produce the enhancer, the how you say the I'm losing that word, to produce the fertilizer, of course. So to use all these economies that are related to the sea in a circular manner, get the discharges and use them as fertilizer to pump to put in the system. Because of course the fresh water we produce, it's distilled. It's just evaporated water. So we need to add some fertilizers in the hydroponic system. That is the only adding that we need to do. The use of energy, because there is some energy, we have sensors and stuff, it's minimum compared to a vertical farming. And we usually produce it with solar or wind, depending on where we are. But that, of course, is an option. We have a lot of partners that can provide floating solar and different solutions to produce. And that is another area of research we're into it. So it is an open research book in this moment. But now we have proof of concept on many things. We have clients, we have different feedbacks, positive feedbacks, and people that want our stuff. So it's a very good moment for us. We need to it's a good moment to start scaling. Yeah.
Wonderful. So on that, yes, scaling is always a big issue with this type of investment. But what is so interesting about your approach from the outside is that it meets many, many different objectives in sort of cohesively, not there. So it's and the way that you produce has no real incremental impact in terms of CO2 emissions. In fact, perhaps as a negative. So even though it may be very big, it shows that your approach does take account of nature and the ways in which nature can, through proper technological assistance, really be a solution for what we find in terms of land use and intensive farming and the effects on the environment. So with that, I would like to thank you very much